friends at home and everybody here in school today, we're going to continue to work on area, and we're going to find the area of composite figures. Remember, composite figures are two rectangles that are pushed together. And we all know how to find the area of a rectangle, right? We can multiply the side lengths. But now we're working to find the area of two rectangles that have been pushed together. Okay? Now, I want you to think about this composite shape here. So the gray part is the composite shape. And think about the composite shapes we did yesterday. If you can't remember, look at your previous workbook page. Your previous workbook page looks like this. What's the difference between these composite shapes we worked on yesterday and the composite shapes we're going to work on today? Now, what's the major difference? The difference between these and these? There. Okay, that's one thing. We labeled those A and B. But another bigger difference, when you just look at those two pages, you can go back in your workbook to look at page 4, page 73. What's the big difference between page 73 and 72? Jackson. Connor, what's the big difference between page 73 and 72? Well, you're really close. Close. Jackson. No. How about the one, Malia? What's it? No. The big difference, boys and girls, here. The big difference is on these, the composite figures are tiled. On here, the composite figures are not tiled. Okay, that's the major difference between yesterday and today. So let's start with our example up here. Okay? It says subtract to find the area of the composite shape. Well, we all have to know what the area of the composite shape is, or what the composite shape is. The composite shape is the gray part of this figure. So take your finger and trace just the gray part. That's what they want us to find the area of, just the gray part. Do it a couple times so you know what the composite figure is. You see it looks like two rectangles pushed together. Okay? And then they have this white part here that is not part of the composite shape. So let's think about it. We have a big rectangle, and then we have a smaller rectangle that is kind of cut out. How could we find the area of the gray part of that shape? How could we find the area of the gray parts? Cool.
You can multiply the side lengths.
Of what?
The big gray.
Okay, we can multiply the side lengths of the big rectangle. If we find the area of this, and then we find the area of the white part, we can do what? We can subtract the white part, and we'll be left with the gray part. It's another whole concept, isn't it? Okay, so we're going to start with the area of the big rectangle. So this is what I want you to write on your paper. We're going to write area of, and we're going to put L for large. And now trace the large rectangle with your finger. The large rectangle is this, the whole thing. So the sides that we multiply for the large rectangle will be 6 centimeters for this side and 6 centimeters for this side. So let's go ahead and write that. The area of the large rectangle will be 6 centimeters times 6 centimeters. And what does 6 centimeters times 6 centimeters equal, everybody? It equals 36 square centimeters. And now let's just refresh our memory. What does 36 represent? The area of the large, not the gray, but the large rectangle. We're trying to find the gray part, but 36 represents the area of the whole thing. Okay? Now, I think we said we could subtract or cut out the white part, right? Well, what is the area of the white rectangle? So let's write another number sentence. And notice how I put a little W. That stands for area of the white rectangle. And sure enough, we have the side lengths of the white rectangle, don't we? This side is 2 centimeters, and this side is 4 centimeters. You can trace that with your finger if you want. So what do we multiply to find the area of the white rectangle? We multiply 2 centimeters times 4 centimeters. So let's go ahead and write that. 2 centimeters times 4 centimeters will give us 8 square centimeters. Now, if 36 represents the whole rectangle, and 8 represents the white part, what can we do with those two numbers to find just the gray part? What can we do with those two numbers to just find the gray part? Jensen.
36 square centimeters minus 8 square centimeters.
Bingo. Nice job. I don't know if everybody heard him, especially our friends at home. We're going to take 36 square centimeters. Why? Because that represents the whole thing. And then we're going to take away or subtract 8 square centimeters. Why? Because we want to take away this part right here. It's like taking scissors and just cutting it out of the other rectangle. We're taking it away. So what is 36 minus 8? 36 minus 8 is, Lucas? 28 square centimeters. So what is the area of the composite figure, the shaded part? The area is 28 square centimeters. 36, one more time, represents the area of the whole rectangle. 8 represents the white part that we're taking away. 28 represents the part that is left. So this is 8, this is 28, the whole thing is 36, part, whole. Okay, let's turn to our next example. Okay, again, we only want to find the shaded or the gray part of this rectangle. Do you think our same strategy is going to work? Could we find the area of the whole rectangle and find the area of the white part and take it away? I think we could. So let's see if we can find the area of the large rectangle. So again, I'm going to write area and I'm going to put L beside it for the large rectangle. And then let's look at the side lengths of that large rectangle. Well, this side is 4 inches, right? And the other side, if you trace it, the other side is 6 inches. So the area of the large rectangle will be 4 inches times 6 inches. If you do your math, you know your facts. It's important that you know them. 6 inches times 4 inches equals 24 square inches. Again, let's remind ourselves, what does 24 square inches represent? Represents the area of this whole large rectangle. Now, same strategy will work. We can find the area of the white part, and then we can take that away from the big one. It's like we cut that little part out. So again, we're going to write area, and we're going to put a little W by it for area of the white. Go ahead and write your own number sentence for the area of the white. You have your side lengths. All right, so I saw several people for the area of the white rectangle. This is the white rectangle. The side lengths are 2 inches and 3 inches. So they took 2 inches and they multiplied by 3 inches and they got 6 square inches. All right, if the whole thing is 24 and this is 6, go ahead and write the number sentence to find just the shaded part. What will you do to find just the shaded part? I see most people got that done, and this is what most people did. They said, well, I'm going to take the 24, which represents the entire thing, all of this, 24 square inches, and then I'm going to take away this, which was 6 square inches. And so we want to find just the gray part, that composite shape. 24 minus 6 equals 18 square inches. Okay, fifths to 5. How do you feel about that skill? No tiling. How do you feel? 5, you could teach it to a friend. 4, you can do it, but you're not quite confident enough to teach it to a friend. 1, it's like I'm up here talking in French or alien. Okay? So somewhere, okay, very good. You don't have to be a 5 just yet. We don't expect you to. But hopefully it makes sense to you. We have another example. This one we're going to add another little challenge to the problem. So go ahead and turn your page and look at the next one. It is a big one. Take a minute and look at this one. We still have a big rectangle, right? Everybody see the great big rectangle? We still have a white one that we can cut out a bit. But what creates more of a challenge with this one? What do you see that might trip us up, that we have to figure out before we can find those areas? Nevaeh, what's your problem with it?
You have to be able to multiply 11 with 9.
Well, you're right. We do have to know how to multiply 11 times 9. That's a harder fact. I agree with you. So thank you for that. But there's something else on here that might be tricky for us. Isabel, what's the problem?
What if you have to, figure out this on this for the white?
Very good. There we are. We got a couple unknowns there, don't we? Thank you, Isabel. We need to find the length of the white rectangle, the two side lengths. Now, can we figure out how to do that? One thing you need to know is opposite sides in a rectangle are equal. So when I draw a rectangle like this, if this side is 3 inches, this side will be 3 inches. If this side is 7 inches, then this side will be 7 inches. So that should help us figure out this missing side length. So first I'm going to look over here and I'm going to say, well, this side is 9 feet. So this side has to be 9 feet. So I say to myself, 4 plus what equals 9? Well, everybody, 4 plus what equals 9? 4 plus 5. There you go. There's your missing side length. Easy peasy, huh? It's a little bit like a puzzle you have to figure out. Okay, now we'll do the same thing for the bottom. If this side is 11 feet, guess what? This side has to be 11 feet. So you have to say to yourself, what can I add to 5 to make 11?
6.
Very good. This will be 6. And now, the rest is just like the other 2 examples we did. We're going to find the area of the large rectangle, and we will subtract the area of the white rectangle to find the shaded part of the composite figure. So let's go ahead and write area of the large rectangle. This is the one that Nevaeh said might be difficult for us. What are those side lengths for the large rectangle?
11 and 9.
11 and 9. Very good. So we have to know how to multiply 9 feet times 11 feet. Some of you have already passed your 11, so maybe you can teach us that. What's 11 feet times 9 feet? Avery.
11 feet times 9 feet is
99 square feet. Thank you, sweetheart. So 99 represents what? This whole big rectangle. So if that's 99, now we have to figure out what the white part is. So go ahead and write a number sentence to find the area of the white part. You guys are doing awesome on this. I'm so proud of you. All right. So the area of the white equals side lengths of the white rectangle? They are 5 feet times 6 feet. Most of you got that, so nice job. 5 feet times 6 feet equals 30 square feet. Let's remind ourselves, what does 30 square feet represent? It represents the white part. What does 99 square feet represent? The entire thing. So what will you do with those two numbers to find just the shaded part? What will you do with those two numbers? 99 and 30. What can I do with them to find that just the shaded part? Isabel? Subtract. Very good. It's like taking the whole thing and taking scissors and just cutting this out. So our next number sentence will be 99 minus 30. 99 minus 30, that's easy. 69 squared. And that's the shaded. Okay? So, in today's lesson, most of the time we completed a composite figure and subtracted a part that was missing. Now, you get an opportunity to do this in your workbook. Okay, so go to page 73. Friends at home, I've uploaded page 73 and a seesaw template, but you can also do it in your workbook and take a picture. Just make sure that your teacher can see your work. Go ahead and read the directions, boys and girls. This is what page 73 looks like. We have another composite figure there, don't we? And thank goodness we aren't missing any of our side lengths. They did give us a number sentence. We need to find the area of the shaded part. This says the area of the shaded figure equals something minus something. Well, we can't subtract until we find the area of the whole large rectangle and the area of the white part. So we need to write two number sentences before that. We need to find the area of the large rectangle. When we're done finding the area of the large rectangle, we got to find the area of the white rectangle or small rectangle. And then we know what we're going to subtract. So I'm going to give you guys a couple minutes to see if you can do those two on your own, and then we'll come back together. So find the area of the large rectangle. Remember, you can trace it with your finger. Then find the area of the white rectangle. You can trace that with your finger. Once you have those two areas, you should be able to fill out your subtraction sentence. We'll come back. Remember, that number sentence they've given you is for the subtraction part. You have to write your own.
Very good. Excellent. Now, if you distribute it, what are you going to do? Something?
Okay, looks like most of you got that. Very good. Okay, area of the large rectangle. Well, what are my side lengths? It looks like they are 10 centimeters and 9 centimeters. Remember, the large rectangle is this rectangle right here. So I saw a lot of you write 10 centimeters times 9 centimeters, and you got 90 square centimeters. Then if we wanted to find the area of the white part, well, the side lengths are 4 centimeters and 3 centimeters, so we multiply that. 4 centimeters times 3 centimeters gives us 12 square centimeters. And then here is where we find the area of just the shaded part. They gave us a subtraction number sentence to fill in. So what numbers will we put in that subtraction number sentence? Mia? Yeah, you don't have to dress up your numbers because they didn't really give you a number. So 90 minus what, honey? 12 equals not 88, 90 minus 2 would give you 88, but 90 minus 12 is what, Bolton? 78. So the area of the shaded figure is 78 square centimeters. Okay, turn to your neighbor right now and tell them how you found the area of the shaded part. Tell them the steps you took. Say, first I did this, next I did this. What did you do first? Well, those are the segments. First we found the area of the large rectangle that we did here. Then you found the of the white rectangle. And then what did you do? You did not get them. All right, who would like to explain to me the steps you took to find the area of that composite figure? Avery, go ahead. First?
First, I did the
Very good. So first you found the large area of the large rectangle. Then what did you do? Okay, then she found the area of the smaller, the white rectangle. And then what did you do? So then you subtract the area of the small rectangle out of the area of the large rectangle. Makes sense, doesn't it? Okay, let's go on to the next one. The next one is the tricky one because we do have some missing side lengths here. I'm going to see, because it says the figure shows a small rectangle cut out of a big rectangle. A says label the unknown side length. So we have an unknown side length here and an unknown side length there. I'm going to do this one with you, and then I want to see how many can do this one on their own. So, if this side is 9 centimeters, what do we know about this side? It must also be 9 centimeters. This is 4 centimeters, so I ask myself, 4 plus what gives me 9? 4 plus 5. Okay, now you guys do it for this side. This side is 7, so this side has to be 7. So go ahead and find the missing side. All right. Nevaeh, what will this missing side length be? If I know this is 7, then this will be
7.
Oh, I don't think so. This whole thing is 7.
It will be 5.
Why 5? No, it's not. It's this side. So if this side is 7, everybody, this side has to be 7. So what do you ask yourself? What plus 3 equals 7, right? Or what is it? 4. Very good. 4 plus 3 equals 7. You see that? Okay, go ahead and label it. All right, now, the next one, they did give you the number sentence. They want you to find the area of the big rectangle. Go ahead and trace the big rectangle with your finger and write your number sentence to find the area of the big rectangle. What are the sentences?
over here, but here.
All right, what number sentence did you write for the area of the large rectangle? I'm going to trace it one more time. It's really important that you know what the large rectangle is. It goes from here to here to here to here. What are my side lengths that I need to multiply? Lucas.
You have to multiply 9 times.
Very good. I'm going to start with my 7. So 7 times, and this whole thing here is 9. If you're not comfortable doing that, you can say 7 and 9, look along the bottom. 7 times 9 is what, Gunnar? Remember, you can say to yourself, 1 less than 7 is 6. What do I add to 6 to make 9? 3. My answer is 63. Okay, now find the area of the small rectangle. Go ahead, you have your side lengths. It should be easy for you. All right. Looks like most people wrote the number sentence to find the area of the small rectangle or the white rectangle was 4 times 5 or 5 times 4, whatever you're more comfortable with. 4 times 5 is an easy fact, it's 20. Now, how do I find the area of just the shaded part? You guys know what to do with those numbers. Go ahead and do it. Find the area of the shaded part. Remember, we're going to take the large rectangle, and what are we going to do? We're going to subtract the white part. All right, this is the number sentence. Hey, Ryder, tell us what number sentence you used to find the area of just the shaded part. What did you use? 63 square centimeters, which represents the large rectangle. Then what did you do? Excellent. And what did you get? Excellent. 43 square centimeters. All right. So just for our friends at home, who would like to come up and play teacher and just explain the steps we took here to find the area of the shaded part? Jensen, come on up. You can point to the board. Talk nice and loud so your friends at home can hear you. So go through the steps. First we did.
First off, we found the
Missing side lines.
missing side
Very good.
for the white. Then we got area of it. Then we times 7 and 9 the difference.
Yeah. So show them what 7 times 9 is. Use your finger.
7 times 9 equals 63.
Is for what on the picture though?
40 and 40.
Okay. Very good, buddy. Nice job. Then what else?
Then we took the white part and we did 4 times 5 equals 20.
Good. And that represented the
The
white part. Very good.
And then we added up the area of 63 square centimeters. And then we minus 3 square centimeters for the white. That gives us 43 square centimeters.
Very good. Everybody understand that? We found the area of the large rectangle. We found the area of the small rectangle. We subtracted because we were taking that away to find the shaded rectangle. Nice job, Jensen. Okay, boys and girls, very good. If you have all that, you may put your things right there.